Hello everyone and welcome to Quadratic. So this video will discuss this year's trial paper, which is from Kedah, and will focus on paper 1. Alright, so let's get right into it. Alright, so for question 1, it comes from the chapter functions, and for part A, we have this function g of x, and it says that if g of x maps to onto itself, find the value of c. Right, so here, what does maps onto itself mean? This means that object will be equal to image. Right, so we know that, let's say, our object is x. If we put inside a function g, it will produce an image of g of x. So maps to on itself means if my object is 2, I put inside this function, it will produce the same result, which is 2. Right, so this means x will be equal to 2, g of x will be equal to 2. So if we want to find the value of c, we will sub this and this with 2. And by rearranging, we will find the value of c, which is negative 4. Right? So for part B, we have this flow here. So this means that, for example here, if our object is x, we apply it to this function, it will produce this image. And if this is the object, if I apply it to q, this will be our image. Alright, so for part 1, we need to find the function that maps set B onto set A. So if you all don't know what does this mean, you can actually go back to the question here. So it says function P maps set A onto set B. This one is the other way around. So this means we want to find the function that maps backwards. So we know that backwards is the inverse function, or this means we need to find P inverse of x. Okay, so we need to find the inverse function. So for the inverse function, we need to go through these 3 steps. Okay, but before that, we need to have 2 equations first. Okay, so the first one would be let y as our current function, and with this equation as well. So if you're wondering where did this come from, it's actually if I move p to the other side, it will become inverse, correct? So here would be p inverse of y, and here we have left x. Okay, this is one of the way to remember this. Right, so let's go to, so this is our equation, and we'll use the first step, which is to use the first let equation. So for the p of x here, I would change it to y. Okay, so this is our first step. Second step, let x as the subject. So this means that I will only remain x on the left side, and everything move to the right. And the third step is we need to use the second let, which means we need to change this x to be p inverse of y. Okay? Right, so now if you go back to the question, it says find in terms of x, but our equation here is only y. Right? So what we need to do is we need to change all the y's to x to fit the question's criteria. Right, so this is our inverse function. And for part 2, we need to find the function qx. So if you look at this diagram, we have 2 sets which involves q. Right, so if we write it into a function notation, it will be something like this. This is our object, we put it inside this function, and it will produce this image. Okay, but the issue here is the things inside this bracket is not x, like if you see this question. So this is actually a composite function problem. So composite function means there are 2 single functions and it can in-group together. So this is a composite function. So now the issue is we need to find the function on the outside. Okay, so to find this function, we need to follow these 3 steps to find the function outside. Okay, so the first step is to sub the given function. So this we actually done it because previously it was p of x, and now we already sub it with 3x minus 3. Okay, so this is done. So the second step is to let x as the subject, but this one, before that, we need to let the things inside this bracket to become y first. Alright, and we only let x as the subject. Okay, then for the third step, we should change everything here which has x to become y. Okay, so for this 3x minus 3, it will become y. So here on the left side will be q of y. And for the right side, this x will become this. So we sub it here and we simplify it. Okay, so same as part 1, it says in terms of x, and you can see the function, it says q of x. We need to change all our y's to become x. Okay, so this is our final answer. And for the answer scheme for this question, you all can refer to the end of this video. Question 2 comes from the chapter Quadratic Functions, and if you want to understand this even better, I have already drawn out this graph. Okay, so to find the value of k is quite easy because the dot from here and here is actually 5 meters away. Alright, so if you want to find the value of k, we just subtract 4 with 5. Right, and the k will be -1. And for part B, we need to form the function of this dolphin's movement in the intercept form. Right, there's a slight error here. And these are two things we need to know: function and intercept form. So what is intercept form? So this is the intercept form. So here, p and q actually represents the roots of the quadratic function, which is -1 and 4. Right? So we can sub it here, but there's one issue, is the value a. So why we need to put this value a is because a controls the shape of the curve. Okay, so meaning if the a has a very large value, it will be slightly longer. But if a has a slightly lower value, it will be slightly shorter. Okay, but now we don't know the shape of the curve, so that's why we need to put the value of a here. If we don't put here, the function will be incorrect. Okay, so to find the value of a first, we can use the coordinates of the dolphin, which is -2 and -3, and we sub it here. So this f of x, which is y, we can sub it with -3, and x we sub with -2 to find the value of a, which is -1/2. Right? So now we can sub this value of a inside, and the roots here, which is -1 and 4. So make sure here you note that this is negative. Okay? So this would be our answer. Okay? So I highlighted function is because sometimes we will make a habit that this is y. Okay, so make sure you don't write this as y, make sure you write it as f of x because it is a function. And for question 3 comes from the chapter Differentiation, right? So we have two equations and we need to find the dy dx using the chain rule, right? So to remind you all what is chain rule, is actually this. So dy over dx, I can split it into two fractions, okay? dy and dx, and the part here I can substitute any kind of quantity according to the question. So here we have y, t, and x. So I can put this t here and here. Alright? So to find dy over dx, we need to have these two differential equations. Okay? So to find dy over dt, we need to find a function that has y and t. Okay? Or sorry, an equation that has y and t. Okay? So it's this one. So let's differentiate this equation. So dy over dt, or power will move to the front and multiply with 1/9, it will be 1/3, and t here, so the power here will -1, it will become 2. Alright, so t and x as well, I can use this equation, but since here the t is on top, so I will rearrange this equation first to let t as a subject. Okay, t on the left side. So it will be something like this, and then we differentiate. So dt over dx. So this one I just pull the value, and this one if we differentiate, it will become 0. So we have left with 1/2 only. Okay, so once we have these two differential equations, we can multiply and to find the value of the equation of dy over dx. So here we need to be careful because here it says dy over dx, so we would expect something with x instead of t. Okay, so to change this value of t, we need to substitute using this equation because this equation has x. Okay, so let's sub this inside here. right? So here the 24 actually comes from here. So the denominator, I combine them together because it's the same, and then I apply this square to here, to 2, so it will become 4, and we multiply with 6, okay? So it will be 24. And don't forget, we have another part for this question, which is we need to find the value of dy dx if our x is 2. Okay, so let's sub this with 2 to find the value. Right, so we will get 27 over 8. And for part B, we have this equation, and we need to find the value of a, which is here. Okay, so this is actually not very complicated. We need to understand part by part what does each of the value mean. Okay, so this part inside this bracket is actually the original function. Okay, original function. Reason is because if you see on the outside, there's this f prime. So f prime means differentiated. But if we have a function outside which is differentiated, this means this has not been differentiated yet. It's about to be differentiated. So the thing on the right side is actually the result or the differentiated value. Okay, so in order to find the value of a, what we can do is we differentiate this original equation first. Okay, so let's let this as y. Okay, and I will move this 3x minus 2 to the numerator, so the power will become -5. Okay, and let's split it into two parts. X will be u and this part will be v. The reason is because we can use a method from differentiation which is product rule. Okay, so let's separately differentiate these two equations. So du over dx here, if I differentiate, it will become 1. dv over dx, the power I'll move in front, so it's -5. 3x minus 2, power we minus 1 again, so it becomes -6. And we need to differentiate this equation, 3x minus 2. So I will pull the value will be 3 and -2, differentiate becomes 0. So this value we need to multiply here. So our result will be -15 for this part. Okay, so once we have these 4 equations, we need to cross multiply. And we need to add them together. Okay, so if you look back to the question, here the numerator, the power is 6. Okay, and here we have power of 5. If we ignore the negative, here we have 6. Okay, so from these two values, let's factorize 3x minus 2 power of -6 first. Right, reason why we have 3x minus 2 here is because if we split this into 2, which is, if you focus on the power lah, if we split this -5 into -6, the other value would be 1, correct? So because -6 plus 1 is -5. Okay, so now we have these two things, 3x minus 2 power of -6 and 3x minus 2 power of 1. Okay, so since this is already factorized, it will be in front, but we only left with this. So this 3x minus 2 is actually this. Okay, and this part is directly factorized, so here the whole part will disappear, and here we have only left -15x. So this part, I move it back to the denominator, so this -6 will become 6 to tally with the question here. And for this part, we can still factorize it, so here we can factorize another -2 out. So here will become something like this. Alright, so this will be our final form, which is exactly the same form as the questions. So here our A, if we compare, would be 6. And for question 4, it comes from the Indices, Surds, and Logarithm chapter. Alright, so for part A, we need to we need to simplify an indices expression. Okay, so for this part, what I will do is I will split these indices first. Okay, these two. It becomes something like this. Okay, so it will be 3n multiplied by 3 to the power of 2, and here will be 3n power, multiply 3 to the power of negative 1. And then I will calculate its value. So 3 squared would be 9, and 3 to the power of n, and here would be 5, 3 to the power of n. So I add them together, it will become 14, and the 3 of n will be here, and we have left 42. So we will simplify this fraction here, it will become 1 over 3. So 1 over 3, I can still simplify it to become 3 to the power of minus 1, and I can combine with this 3 to the power of n. So at the end, we will get 3 power of n minus 1. And for part B, it's a Surd equation, and we need to find the value of a and b. Okay, so for this part, if you look here, the denominator here has square root, but here we do not have. Okay, so how do we eliminate the square root? What we can do is, for numerator and denominator, at the same time we multiply the same value, which is square root 3. So if we multiply square root 3, square root 3 here, it will become 3. So the square root disappears, right? So this would be our result, square root 3 over 21. So if we compare this and this, a would be 1 and b would be 3, which is the value inside the square root. Right, lastly, this is a logarithm equation, and we need to show that the thing on the left side is equal to the right side. Okay, so this one is actually not quite hard. Okay, so what we do is we look at the the bases first. Okay, we have 9 and 3. So what I would suggest is to, when we want to show something, let's go to a direction where we change the larger logs to the smaller ones. Okay, so let's start from the left side, and we can use these law of logs to help us out. So these formulas are all given in the exam. Okay, so it actually depends on whether do you know when to use it or not. Okay, so this one, for the log base 9xy, I will split it first. So I will use the first equation, the first formula first. So from this expression, now I go backwards. So here would be x and y. I split the x and y first. So this is multiply, so I will add plus. Okay, and now because we need to change it to base 3, so I will use the formula number 4, okay, to change the base. Okay, so the value x here, which is b here, I'll move it here, and the old base, which is a, I'll move it here. Okay, and for the value c, I will use the log that I want, the base that I want, which is 3. Okay, so now 3 and 9, there is a relationship, because 9 can be expressed as 3 power of 2, correct? So now we have the base and the index value is the same. These two, the power, I can use the third formula. The power here, I can move it to the front. Okay, so this value of 2, I can move it to the front to become something like this. Right. And another fact for logarithms, which is if our base and the value is the same, the value will become 1. So this part, it will disappear because it will become 1, this part as well. So now we have left with this 1 over 2 log base 3x and 1 over 2 log base 3y. And the only difference here with the question's equation here is actually the 1 over 2. So this 1 over 2, we can actually use back formula 3. Instead of pulling the power to the front, we now move it back, right? So this 1 over 2, I can move it back to something like this. Okay, 1 over 2, 1 over 2. But we know that 1 over 2 is square root, so usually we won't write it this way. We can just write square root here. And with that, we have actually proved this equation. Alright, next question is from progressions, and for part A we have x and y, which are a positive 1-digit integer, And also for x and y above, there is these two dots. So these two dots means this is a recurring decimal, or meaning a repeating decimal. So let's say it is something like this: 2.xy, xy, 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 and so on. It does not end. Okay, so this is actually explained in the textbook, either in the BI or the BM version, and it is in page 147. So it is at the right bottom side of the page. Okay, so what we need to do now is to change this recurring decimal into a fraction. Okay, so the first thing is, let's let x and y as a value first. Okay, and then let's express this decimal into this. And now we will split this according to some separators. Okay, so the first separator would be using this decimal point. Okay, and the next separator would be according to the decimals pattern. Okay, so we have 56, 56, 56. So we will split according to its pattern. So 56, then we split, 56, then we split, and so on. Okay, so now we split it according to what we have separated. Then it will be something like this. So 2, I will just pull it down. So when I pull 2 down, this will become 0. And I will pull down 5, 6. So here will be 0.56. And if I pull down this one, it will become 0.00 because this I already pulled down. So here it will appear 0, 0. And so on. Okay, so if you focus on these 3 decimals, right, you can see that from one value to the next, we have a pattern. What the pattern is, we need to multiply 1 over 100 to get the next value. Same goes to here as well. So this actually means this is a geometric progression, or GP for short. For one value to the next, we need to multiply or divide a value. Okay, and now you can see that these values are all added up together. So this means that sum is involved here. And you can see that here there's no end. Means it is infinite. So what we need to do to summarize these values is to use the geometric progressions sum of infinity formula, which is this. Okay, a over 1 minus r to summarize all of this. So here the 2, I will just put it down, and 0.56 would be the first term, which is the a, so I'll put it here. And for the r would be 1 over 100. Sorry, this is a bit distracting. Yep, so r would be 1 over 100, or 0.001. Sorry, 0.01. Right, so we simplify this, we will get 2 plus 56 over 99. So this 56 is actually our xy. And if we compare with the question, P will be 2 and Q will be 99. Apparently we have Kumar climbing a pole. So for every 3 seconds, this is his performance. So here would be 100 cm, 95 cm, 90 cm, and so on. Okay, and the question asks that if Kumar would like to win this competition, he needs to reach at a height of 1060 cm. Okay, so the question asks, did Kumar succeed in order to reach this height? Right, so how can we verify this is by looking at the pattern first. Okay, so if you see here 100 cm, 95 cm, 90 cm, so from one value to the next, we need to minus 5. So this actually is a arithmetic progression, or AP for short, because we need to either add or minus one value to get the next value. Okay, so if you look at here, it keeps on minusing 5 cm. So we will reach to a point where it will reach 0 cm and approaching a negative value. So we do not want to include this because we want to see whether Kumar can actually reach at a maximum height of 1060 cm. So we need to avoid all the negative values and we need to add up all the positive values. We need to add up all together. So the question is, what is the term that it will become negative in the first place? Okay, so this is what we need to find. We need to find where our Tn is less than 0. The n is the thing we need to find. Okay, so according to AP, this would be our formulas. So Tn, I will use this, A plus n minus 1 multiply D. So our A would be the first value, which is 100, and the D would be negative 5. Right, so if I simplify this, I will get this value. Okay, and then this 105, I'll move it to the right side, it becomes something like this. And the negative 5, when I move it to the right side, make sure I will change the sign of the inequality. Okay, so please remember this. So now n is more than 21, and we just need to find the nearest whole number, which is 22. So this 22 means that this negative 5cn is the 22nd term. So from the 22nd term, all the values are negative. Okay, so this means we need to add up the first 21 values. Okay, so we can use the Sn formula to help us find. So the n will be 21, so I will put 21 here. A would be 100, n is 21, D is minus 5. Okay, so if I use calculator, I will get 1050 cm, which is actually less than the required height. Okay, so this means Kumar did not succeed to win this competition. Alright, next question is from linear law, and we have these 2 points which lies on a curve, and we have this straight line which is using log base 10 y and log base 10 x as the axis, and we need to find the values of p and q. So for this chapter's paper 1 questions, we need to ask ourselves the one question, which is, are we changing from non-linear to linear, or the other way around? Right? So if you look at the value of p and q, all actually depends on this straight line. Okay, so it's very obvious that we need to change from non-linear to linear for this case. Okay, so in order to change this, from non-linear perspective is xy, and linear is log base 10x log base 10y. Okay, so here to change this to this, what we can do is for x, which is 1, then I will find the value which is log base 10y. Okay, which you can see what I have demonstrated here. So log base 10(1), I can just type it into our calculator to get 0. Same goes to the y coordinate as well, okay, which we'll get negative 1. So here our first point will be 0 minus 1. So for 10, 10, this coordinate is also the same thing, and we will get 1, 1. Right, so let's find the value of p, which is this gradient. So if I use this as the first point, this as the second point, and by using the formula y1 minus y2, x1 minus x2, we will get gradient, which is 2. And for the other point, which is this q3, we need to have the straight lines equation first, because now we don't have. Okay, so what we need to do is, for m we already have, but we need to find the value of c, which is the y-intercept, which we have already found, which is here. As we know, y-intercept, the x value must be 0, correct? So this c will be negative 1. Okay, so now I have the value of m, which is 2, c negative 1, and this coordinate 3q here. Okay, so I can find the value of q. So our value of q will be 2. Alright, question 7 is from coordinate geometry, and for the information here, I have already drawn into this diagram 7. Okay, so to let you know that the point M is actually the midpoint of AC and BD. Okay, so for the first part, we need to find the coordinates of tent D. So if you can see, for point D, this is actually one of the lines which has the midpoint. So we can use the midpoint formula to help us find the coordinate D. Okay, so for the coordinates D, I will put it as xy, which I have put here. The midpoint, which is 1, 2, I'll put it here. And for the other point, which is 7, 6, I'll put it here. Okay, now we can compare left side with left side, right side with right side. Okay, so you can see 1 will be compared with this, and so on. So now I can separately find the value of x and y, which is negative 5 and negative 2. So this would be the D 10D coordinates, which is negative 5, negative 2. And make sure you write it in this way. Do not stop until here. You won't get the marks, okay? Right, so for part B, there's a rope stretched between 10B and 10C, as you can see in this diagram. Okay, so we need to find the equation of this rope in the general form. Okay, so there are two things I would like to let you all know. So to find the line equation, you just need one gradient and one point. So now we have already the point. Now it's just this gradient that we don't have. And also, general form means once we found our equation, we need to let it be this format. So right side would be 0. A, B, and C needs to become an integer. It cannot be a fraction. Okay? Right, so let's find the gradient first. But before we find the gradient, we need to find the coordinate of C first, right? So using the same way as part A, because C is actually one of the lines which has the midpoint, so we can use the midpoint formula again to find the find the coordinate of C. Okay, same way as well. So once you use the same way as part A, you will get the coordinate is 3 minus 1. Okay, and now using 10B coordinate as the first coordinate, this as a second coordinate, we can use the gradient formula, which is used in question 6 just now. So once we use the formula, you get 7 over 4 as our gradient. And now we need to find the y-intercept. Okay, so if I use this gradient, and if I use this coordinate, which is here, 3 and minus 1, sub into x and y, I will find the value of C, which is negative 25 over 4. Right, so I plug in my gradient and y-intercept and form my equation into the general form. Okay, so I move everything to the left side, which is like this. And since there is fractions here, so I multiply the whole equation by 4 to eliminate the denominators to get this general form of our equation. And for part C, we have a safety tape that will be installed between D and M. Okay, so the condition is the distance of the safety tape from two fixed points, which is D and M, must be the same. Alright, so an example would be somewhere here. Okay, so if you focus on this point, the distance between D and M is the same. Same goes to the point up here as well. The distance between D and M is the same. D and M is the same. So if we let this blue point as xy, so all the possible points of xy would be somewhere here. So later, our equation of locus will be something like a lines equation. Right, so now to find the equation, let's use the distance formula since it uses the distance as the condition. Okay, so for firstly, I will find the distance between D and the blue point first. Okay, so the blue point's coordinates we don't know yet, so we'll put x and y. And for the coordinates of point D would be negative 5 and negative 2. So this is the first one. The second one would be with point M. So for the blue point's coordinates, I'll put it here, same as the one above. Then I will sub the coordinates of M, which is 1 and 2. Okay, so now I will consider its ratio, because it says the distance between these two is always the same. Always the same. So what I can do is, if these two are technically divided together, the value would become 1. Correct? Because both of them, if we divide, would be having the same value, because it says always the same. Distance between these 2 points, always the same. Okay, so this is how I will form my equation of locus. So this is technically a formula if we want to find the locus with 2 fixed points. So our 2 fixed points would be D and M. Okay, so for any kind of question which has 2 fixed points, we can use this formula. So if the ratio is different, let's say it says the distance between D is 3 times then the distance between with n. So it would be something like 3 over 2. So you can write your ratio to be something like this, 3 over 2. But for our case, this will be a special case, which is 1, 1. Okay? Or 1, because it is the same. Okay, so now to simplify this, let's apply square to both sides. And let's expand the values here. Okay, so if you expand and apply square, you get something like this. Okay, then I move everything at the bottom to the right side. And I further simplify. So here I will cross off x squared, cross off y squared, and add up the values together, we'll get this equation. And I divide it by 4. Okay, so we'll get the final equation, which is this. So as you can see, this is actually a line equation because this is similar to our general form equation that we got just now. Yeah, let me share it to you. Yep, this one. Ax plus by plus c equals to 0. Same thing as here. Okay? And for the next question, it comes from vectors. And for part A1, Afika moves from point O to Q, which passes through A and B, and Q is the midpoint of this line. Okay, so this is the route. Okay, so we need to find the magnitude of displacement of Africa. So the magnitude here actually means the length. But the length of what? Displacement. Okay, displacement means the distance between the starting point and the ending point. So we don't need to find the distance from O to A to B, B to Q. No need. We just need to focus on the starting point, which is O, and the ending point, Q's distance, which is here. Okay, so this is the line we need to focus, not the one I have drawn just now. Alright, so to find the magnitude, we need to find the coordinate of Q first. Okay, so since this is a midpoint, we can use the midpoint formula that we used in question 7. Okay, so the coordinates will be 9 and 5. So now the issue is how to find the magnitude using the vector way. Right, so for vectors, we write it in this way, correct? So xi and plus yj. Y actually controls the movement to the left or to the right. J will be up or down. Okay, so to find the value of x and y, let's imagine us that we are really going from O to Q. So we know that the length, if you want to go from O to Q, we need to go 9 units to the right. 9 units to the right means x would be 9, and 5 units upwards. So here our y would be 5 because it moves upwards and j controls the movement of up and down. Okay, so why we need to find the value of x and y is because it helps us to find the magnitude, which is x squared plus y squared, and we need to square root it. Okay, so this is actually the Pythagoras theorem. If you look closely here, this is actually we need to find the hypotenuse. 9 squared plus 5 squared, square root. Or in another way, we can calculate the value of x and y and square plus them and square root. Okay, so to find the to express the vector's magnitude, it'd be something like this: 2 vertical lines, and we put the vector in the middle. And here we can use the Pythagoras theorem or the formula, which is 9 squared plus 5 squared, square root, and we will get 10.295 units. And for the second part, which is another person, Imran moves from point A to C. Okay, point A to C means somewhere here. Okay, I will use O as the connector, so A to O, O to C. So using the law of triangles, okay, so this means that if I start from this point, I go through X and I go through Y. If I use another way, which is something like this vector is actually the sum of these two vectors, X plus Y. Okay, so Now we need to find the Imran's movement in the column vector form. Okay, so column vector actually is quite simple. It's just another way to express our vectors. So for the value of x and y that we have in here, we just write it in a vertical way, and we just add brackets on the sides. Alright. So now to find the Imran's movement in the column vector form and using the law of triangles, so this is the way how we do it. So as you know, A to C is this line. So in order to use the law of triangles, we need to find the vector for this and add them up together. Okay, so in order to find the vector AC, I will use this way: A to O plus O to C, using the law of triangle way. Okay, now how do we express this AO into a column vector form? Again, use the same way as part A1. We imagine we are going from A to O by going up, down, left, right only. Okay, so here, if I am here, I need to go through this line first. So it's going 2 units to the left. Why 2? Because here it says 2, the coordinate. Okay, so here would be -2. And now I need to move downwards. So here it starts from 6. So I need to go 6 units downwards. So it will be -6. Okay, OC, same thing as well. OC here, our coordinate is 8, 2. So this means I need to go 8 units to the right, 2 units upwards. So here will be 8, 2. Okay, so if we add them up together, it will be something like 6 minus 4, which is our answer. Okay, another easy way to understand this is AO, right? Because it's the opposite way. Usually we go from O, which is the origin, to A. So if it's the opposite way, we can just use the coordinates and we just add a negative. And if you see OC, we are going from the origin to the coordinate. So you can see we are directly using the coordinates to put it here. You see it, right? 8, 2, and I write it here, 8, 2. So if it's the other way around, I need to add negative. And for part B, we need to find the unit vector of vector AP. But first we need to find the vector of AP first, alright? So here AC is actually found in part A2. Okay, so let's find the vector of AP first. So we know that AC is actually 6 minus 4. So let's express it into the expression that we are more familiar with. Okay, so I multiply the value, which is 4i minus 8 over 3j. Okay, and now we need to find the unit vector of AP. So we need to have two things. One, the vector. Two, the magnitude, which is the length. So the unit vector means that, okay, if I have, so let's say this vector, the length is actually 3 units. So unit vector means that what is the vector that if I only want 1 unit of the vector, just 1 unit, so what would be its vector? So this is why we are dividing vector with its length. So I will be able to know what is the vector if this length has only 1 unit, which is why it's called unit vector. Okay, so for the vector, I will need to put it here for I 8 over 3j, and the magnitude will be using the Pythagoras theorem, 4 square plus minus 8 over 3 square. Okay, so once I simplify, it will be something like this, and then I need to simplify this square root. So this is the value. Okay, so the 9, if I put it out, we need to square root 9, so it become 3. And oh sorry, apologies here, this will be 4. So this 208, when I split, it will be 13 times 16. Okay, so this 16, if I put it out, will be square root 16, so it will be 4. And in the square root, there will be 13 only. Okay, and then I will just divide 4 over 3. Sorry, the 4 and minus 8 over 3 will be divided by this value, 4 over 3. Okay, so the final expression will be something like this. Alright, question 9 comes from the chapter circular measure, and here there's a lot of information, so I will highlight and also to draw some things on this diagram 9 at the same time. Right, so the first thing is for this circle with center P, we need to plant grapes, and the other circle we plant strawberries. So here there's a minor sector MPN, and the angle would be 2 over 3 pi. So minor sector means the smaller part of the circle, okay, this here. And the major sector MQN, so it will be somewhere outside, and this is the angle, 5 over 3 pi radians. And the radius here is S for circle P, and it also gives us a ratio, so grape plant radius to strawberry plant radius is this value. So if we know that grape plant is S, this means that strawberry plant is square root 3S, which I have drawn here. Okay, and the area of the land is K, so means the whole land including the white color parts, which is K. So we need to show that the area of tile is this value. Okay, so the area of tile is the shaded area, okay, the part outside. So what we need to do is we need to use K minus out these white color parts. So to find the area of these white color parts, let me draw another line between this 4-sided polygon. Okay, so now you can clearly see that we need to find the areas of 2 sectors, which is here and here, and we need to find the area of these 2 triangles. Okay, after we found these 4 areas, then we minus with K. Right, so to find the area of vector and area of triangle, we can use these 2 formulas. So the area of triangle comes from the chapter Form 4, chapter 9, solution of triangles. Okay, so to find the area of tile, first K, the area of the whole land, minus out these 4 areas. Okay, the first area is the sector, so 1 over 2 radian, the radius is S square, and theta. Theta here we will use in the radian form, so this would be this part. So as we know, 360 degrees, which means the whole angle, is actually equivalent to 2 pi. So here would be 4 over 3 pi, 2 minus 2 over 3. Okay, so here is 4 over 3 pi, and we need to add the area of the triangle. So here the sides is S. Oh yeah, so another thing to note is that to use this formula, we need to satisfy this condition, which is we need to have 2 sides of the triangle, and we need to have the angle between them. Then only we can use this formula. So here we have satisfied the condition, right? The size is here, the angle is between them. So here I will just use the formula 1 over 2 S. Okay, sine. This one is 2 over 3 pi, which is in radian. So I will suggest y'all to use the degree form here. Okay, because our calculators are all in the degree format. So I would like to prevent the case where we need to change back and change again. Degree to radian, degree to radian. So you can save this worry. Okay. So this 2 over 3 pi, I will change it to 120 first. So the next triangle, same thing as well. Here will be square root 3s, here will be square root 3s because it is the radius, and here the angle would be 2 pi minus 5 over 3 pi, so it's 1 over 3 pi. Okay, so satisfy the condition again. The sides are here, and we have the angle between them. So 1 over 2 square root 3s sine. So this one is 1 over 3 pi, so if we change it to degree, this is 60. Okay, and lastly, the last area, which is this sector. So here would be 1 over 2, r would be square root 3s, theta would be 5 over 3 pi. Alright, so once we simplify this, before that, sine 120 I will simplify into square root 3 over 2. Same goes to sine 60 as well. Okay, so once we simplify, it will be something like this. And to get to the final line, I will add up these two values together. So 2 over 3 plus 5 over 2, it becomes 19 over 6. Okay, and we remain the pi lah. So this s square, I will move it outside of the bracket. Okay, so it will appear here. And for these two values, if I add them up together, it will become 4 square root 3 over 4 s squared. Okay, so I can cross off the 4, and we have left square root 3 here, and the s square again, I will put it out, so there will be s square here again. Right, so if we do this, we will get the same format in the question. Alright, so from question 10 comes from the chapter Differentiation, and here